Hi, welcome to AP Daily, Computer Science Principles, Topic 3.8, Iteration, Video 3. My name is Bradley Bearden, and I teach in Dadeville, Alabama. And I want to encourage you to invite a friend to take computer science. So what will we learn today? Well, we're going to be looking at iteration, but in particular, we're going to look at writing iteration statements. Remember that iteration statements can change the flow of the program, and that with repeat until, you really need to pay attention to that stopping condition. The two main types of pseudocode that we focus on in computer science principles is the repeat end times and the repeat until. So let's take a look at an example. And we're going to use the starter code, but you'll notice in the starter code there is a missing code. And so what we want to do is fill in that code so that this algorithm here will iterate 6 times. Now, before you just go and try to do the whole code, I want to see if we can find any clues in the starter pseudocode that might help us so that we don't have to do too much work, right? Because if you really take your time and plan it out, you can save yourself some time. So you'll notice that the stopping condition is I equals 6. And that stopping condition only depends on I. Right now, I is 0. And we cannot exit the loop until I is 6. So that sort of presents a problem right now. So that gives me a clue that in my missing code, I'm going to have to adjust I so that I can change from being 0. And if we ever have a chance of it equaling 6. So instead of really looking at tracing this whole algorithm, we're just going to focus on I. Now, because we need to iterate 6 times, we're just going to try incrementing I one at a time to see if maybe that will allow us to go through the program 6 times. So remember, if I is increased by 1 each time, and we're going to repeat until I is 6. So if we were just to iterate through I, this is where we would end up. So you may say that's 7 numbers for I. And we're only supposed to iterate 6 times. But remember, when I is 6, the condition is true and we do not execute the loop. So if we really look at it, we actually have, even though there are 7 numbers, we've only gone through the loop 6 times, which is what our goal was. So this is the correct missing code. So you would take the code and you would just fill it in, and now we would have a working algorithm. Now, I want to adjust one small thing. So to see now what happens, you'll notice that there was a very small adjustment from before to here, and that is that I took that 0 being assigned to I, and I moved that inside of the loop. So I want to look at what happens. So if we go through the iteration, since 0 is assigned to I, it starts out as 0, and then I is incremented to be 1. Well, when you start the second iteration, the same thing happens, and the third, and the fourth, and the fifth. In fact, you will keep repeating this loop because the condition will never evaluate to be true, and that creates an infinite loop. So what I want to emphasize there is, even though that was a very small change of taking that 0 assigned to I and putting it inside the loop, it really had a major impact. So maybe when you're writing your code and whatever programming language you're using, you may try to look and see if maybe it was a small change that you made, or maybe a small change that you could make would have a major impact when you're programming. Let's practice. So I've given you some starter pseudocode here, and there's some missing code, and I want you to pause the video and see if you can't find the missing code that will correctly add the sum of the first 5 numbers. Work with a partner if needed and see what you can figure out. All right, I want you to pause the video. All right, let's see how we did. So just like I was mentioning before, we don't want to just go right into the loop and going through all of the programming without trying to look for clues that might help us figure out about this missing condition. Remember, it's a repeat until, so you can't just say, I want to repeat 4 or 5 times, even though that might work. Okay, but here's the first clue. We want the sum of the first 5 numbers, and end is 5. All right, the next clue is that sum and counter are the only values changing within the loop. So that means that the condition would have to involve either sum or counter, because if not, the start and end values never change. So using those clues about the end value and about sum and counter, let's try to work through this and then see if we can't figure out what that missing condition is. So sum and counter are initialized to 0 and 1. And what we're going to do is go through the repeat loop and see what happens. So the first time we go through the loop, sum changes to 1, counter changes to 2. And I went ahead and added at the top a running total as we go across, and we're adding the first 5 numbers. So I'm going to want you to compare that to something in a minute, but we'll get there. All right, let's run through the missing code again. I'm not the missing code, the loop. So we run through the loop again. This time sum and counter get updated to 3 and 3. And you'll notice that 1 plus 2 is 3. And so that's the running total so far for just 1 and 2. We want to add up the first 5 numbers, so let's keep going. Here, sum and counter get updated to 6 and 4. And you'll notice the sum of the first 3 numbers is 6. Let's go through again. Sum and counter get updated to 10 and 5. And you notice the sum of the first 4 numbers is 10. So we need to go through it one more time. And sum gets updated to 15 and counter gets updated to 6. Now, we don't want to go through it again because now we've added up the first 5 numbers. So you know, sum matches the running total. So I need to stop at this point and not move on any further. Now, remember the clues that we had in the problem. 5 was my ending value. And the other clue is that since sum is the value that I'm wanting to display at the end, counter is probably the condition that we need to look at. So if we say we wait until counter is greater than end, so remember counter is 6 here and my end value is 5. And so that is a condition that now is true and we would no longer advance in the loop. So what should we take away? Well, when working with iteration, you should be able to write iteration statements in pseudocode. Remembering that they change the flow of the program, but that small changes, if you're not careful, can result in an infinite loop, which you would not want necessarily. So be very careful. And remember that in AP Computer Science, we focus on repeat end times and repeat until. Thank you.